help prepare for that. So here we go. 86, number 19. Is that a book problem or a replacement problem?
That's an argument at x equals x.
So it is the same as no. Okay. So, oh yeah, good deal. All right, so arctangent of x. It says integration by parts. So the question is, first of all, do you know that ultraviolet voodoo and integration parts are the same? Okay, so, alrighty. So integration by parts is u. What do you make u? Arctangent, and dv therefore is dx. Yes, dx is the thing you have to account for. Du is, what's the derivative of arctangent? 1 over 1 plus x squared dx, and the derivative, I should say differential, but the antiderivative of dx is x. All right, so by uv, I would get x arctangent of x. It's minus, not plus, and v du is x over 1 plus x squared dx. All right. What's the strategy for the new integral? How are you going to integrate that? U sub. Actual U sub or mental U sub? All right, mental. What's U? 1 plus x squared, yeah? So what's du then? 2x dx. So do you have a 2x dx? I don't know how you were taught this, but I was taught, so if you want there to be a 2x dx there, you can put a 2 there as long as you balance. I don't know how you were taught, or if you were even taught to do mental U sub, or she just wanted you to get U sub down, but that's the idea. Now it is cleanly du over u. So the antiderivative of du over u is natural log of the absolute value of u, and u is 1 plus x squared. So you would say something like that. Okay? You could actually use something if you prefer. That's fine with me too. All right. 15. 8615. Is that still a question? Does anybody need 8615? Okay.
Yeah.
8615, B or A? Or did you even know what I meant by question B? Did you ignore question B? Alrighty then, here we go. 86, alright, so 15 was y equals e to the x squared, which is on the positive side just a harder growing exponential function. On the negative side, that would make negatives behave like positives. It's an even function, so it would be like that. Not that it matters, but you're talking the area between that and the x-axis from 1 to 2. So you've got this kind of region, yay? If you revolve that in question A around the x-axis, tell me, what's better, x or y? X. Why is x better? Because x would be how many integrals? The y would be 2. So we're going to use x, and when I revolve an x slice around the x-axis, what is made? Disk, washer, or shell? Disk. The disk method is pi r squared times height, and the height here is thickness dx. So the only question is, what's r? E to the x squared. Now, I don't know, maybe your question then was, how do I integrate that? And the answer is you cannot. It's not integrable. You are aware, I hope, that not everything can be integrated. That, for example, I could get a good estimate by a lot of different methods, including power series, but there is no antiderivative for that. Okay? So, slap that in the old calculator to get a good estimate. Call it good. B is, what if this is around the y-axis? So, this is around the y-axis. This was meant to give you, or get you thinking about shells. And you might think, well, that was mean. We didn't know shells at this point. I didn't say it was to get you mastering shells. I just wanted you to lay the foundation. Could you Could you do y and get the answer? Yeah, it would be two sets of washer integrals, yeah. We could do that if you like, or we could do it with x. If I use x, what is made? Well, that's a cylindrical shell. Do you want to use x or y? All right, so if we use x, and it's an unwrapped slice of paper like this, or many of them actually, where the thickness is dx. This here dimension comes from the circumference. So what's that? 2 pi, what's the radius? X, okay. This guy here is this guy. What's that? Let's see the x squared, that's the curve, yeah? So volume is 2 pi x e to the x squared dx from 1 to 2. Can that be integrated by hand? Is that integrable? That is integrable. You can use some of that and get there. But I didn't think I said either way, so you can use a calculator again and call it good. You follow? Okay, 8621. Does somebody need 8621 still? All right, 8621 is not replaced. That is a bit of a humdinger. A and B, or just A, or just B? Let's do it all, shall we? So you have an integral from 1 to 3 of 5 halves. I do not mind in my class if you leave off the argument and leave off the differential, but you would have to, if I were going to college, I would probably go a little pickier in case your professor is picky here. I do tend to cut corners sometimes. I'm lazy. All right, so A, find, what was it again? 3 to 5 of 2f plus 6. Okie dokie. What did you do to start? Did you deal with the 3 to 5 first, or did you separate the 2's and the 6's and all that stuff first? Okay, so let's write this as 2 times 3 to 5 of f plus integral of 6, not just a normal 6. That 6 is in the integral. It needs to be integrated separately. And that would be something like 30 minus 18, so that's 12 eventually. We? All right. What about the first part? How do you find the area under f from 3 to 5, given what you have? Yeah, so I go something like 1 to 5, take away 1 to 3 is 1 to 5, 1 to 3. That's 10 minus 5 halves. So when all is said and done, that's 20 halves, 15 halves. I'm getting 27. You agree? Okay, B. B is, if they say f is ax plus b, what's A, what's B? Okay, how do we use that with these? How do you put those two together? Good call. So I could put in place of f ax plus b, and that integral should be 5 halves. The antiderivative is ax squared over 2 plus bx from 1 to 3. If I evaluate that, I get something like 9a over 2 plus 3b minus 1a over 2 plus b. 9a over 2 minus 1a over 2 is 8a over 2, which is 4a. 3b minus b is 2b, and that equals 5 halves. And at that point, there's not much more to do. So I need another fact. by the same kind of thought process, you could integrate 1 to 5 of ax plus b and call that 10. That would get you another a-b equation. And then you could use what to solve the system of a and b? Give me 5 ways to solve a system. Substitution, elimination, instant graphing, Kramer's rule, inverse matrices, guess and check. Okay. At any rate, that's on you now. I will be grading for that for sure to see if you just said you get the point like I just did, or you actually get it. So that means you should do it. 21 check. 25. Question on 25. Is 25 still a pregunta to me? No, I can solve that stupid system, sure. Yes, 25? Good deal. 25 is a humdinger. This, you'll kind of differentiate between the people that do things really well and the people that are saying, whatever I can get away with. The people that want to do this well, you would say I have zeros at 1, a 0 at 1, and a vertical asymptote at 2, yay? The hard part by far is the end behavior. The end behavior, it kind of goes to whether you said, so end behavior, the limit as x goes to infinity is infinity, and the limit as x goes to negative infinity is infinity, so you just said like that, okay? And depending on your instructor, they might be okay with that. But if you wanted to do this well, you would actually find the asymptote out there. If you did, it might look something like this. Has an asymptote. What's x cubed divided by x? What's the power here attached to these coefficients? X squared plus 2x plus 4, yeah? That's the asymptote. Now, still not very graphable. So then you'd say, well, I guess I can easily put that in standard form by completing the square. What goes there? No, try again. 1, and you must balance with a 1. So the parabolic asymptote is x plus 1 squared plus 3. So if you graphed a parabola that is shifted, how? Left 1, up 3, then your asymptote would look something like this. Oops, I missed. Like this. Okay? Cool. So then on the far left side, if I sign tested, I doggone well better get positives, and I would. Negative over negative is positive, so that it could follow this asymptote in a parabolic way. Then it would come down, hit that root, change signs, and head on down. And as far as right of 2, where would it go? It would go right in this kind of little parabola shape. Okie dokie. Parabolic asymptote. That was fun. Okay, 86, are we cool? All right, 87. 15. Uh-oh. 15. 15 is one of the all-time humdingers in this whole book. Which is 22, 25, 21, 25. Okay? 5. Okie dokie. 87, 15. All right. So lines passing through 1, 2, each form a right triangle. I agree. get a triangle that looks like. How's that? Does that mean something? Like this, or like this. Do these triangles have an upper bound? There is an upper bound to the area. What is? I would argue that if you approach horizontal, then the area approaches infinity. So there is no upper bound. This could approach infinitely large area. It is an unbounded area. Luckily, they don't ask for a maximum area. They ask for a minimum area. Cool. So we begin our optimization process. After you have identified what you're trying to optimize, what do? It's hard to optimize something you don't have an equation for. That's the triangle's area, but in this case, we're going to slap it on the coordinate plane, so we'll go xy over 2, yay? What do we typically do after that in optimization? Do we take a derivative in 3 variables? No, we typically try to substitute. Now that is by far the hard part. What is an other relationship? What's some other thing between the variables, x and y? What have you not used yet that they gave? It's got to go through 1, 2 somehow. We got to use that somehow. How can we use that? Y minus 2 equals some slope. I don't know what to put there. X minus 1. What is the slope? Negative y over x. It could be lots of things. It's varying. I don't know, but that's something. All right. So if we're going to substitute, we need to solve this for x or y, yeah? Wow, it's pretty gross. I don't know if it's any better one way than the other. What do you want to do to clean this up and then eventually solve for a variable? What do you want to go for, x or y? X. All right, we're going to solve for x. Okay? So, shall we distribute or clear the fractions? Distribute, okay. Y minus 2 equals negative y plus y over x, yay? All right, then what? Now do you want to clear the fractions? Okay, so if I clear the fractions, I multiply 2 by an x, I get xy minus 2x equals negative xy plus y. If I'm going to solve for x, then I want everything with an x together, yay? So I'd get 2xy minus 2x equals y. X then is y over 2y minus 2, yay? All right. So the area then is 1/2 y and y over 2y minus 2, or y squared over 4y minus 4. You follow? To find a minimum, I need to find where a prime goes. Negative to positive. This is a relative because there's being no endpoints there. So, all right. So a prime by quotient rule, low d high minus high d low over the square of the low. 8y squared minus 8y minus 4y squared. Just doing my thing. Let's see here. 4y squared minus 8y over 4y minus 4. 4y factored out, y minus 2n. Okay, what are your critical numbers? Y equal? Talk to me, people. 0 and 2 and 1. Okay. I'm just going to focus on this. So 1/2, I got positive, positive, and the bottom is a square, so it's already, sorry, positive, negative. Positive, that's negative. So area is decreasing before that. At 1, I'm getting positive, negative, I'm still positive, negative, positive, still negative. And after 2, I got your positive, positive, positive. So area went decreasing, flat, decreasing, increasing. So min area if y is 2. All right, great. That's almost there, but the question isn't what's y. The question is what's the slope of the line that makes the least area. So we need the slope of the line. So if y is 2, then what's x? What, 2 over 2? 1? Okay, so what's the slope of the line? Negative y over x, so negative 2, yay. Okay, that was beauty. Alrighty, 22. What's it here? 22, is 22 still a question? Alrighty. Alright, so this is not without point. They're trying to get you ready for set 90 or 91 or 92, where you learn how to take the derivative of an inverse. You haven't learned how to take the derivative of an inverse yet, whether you know it or not. So question A says, write the equation implicitly. So when you find an inverse, you switch, yeah? So did you use x or y? Or f or y? That's what. I don't personally like y, because now, there it is, but is there anything in there to show that it's the inverse? To show it's different? Or does that still look like a y? That's why I don't like it. See, I really prefer this. The minute I switch, now I can call it something. F inverse. But that's it. Neither here nor there. Either one's fine. B says, evaluate this. Hi.
Hi, this is Tanya.
Thanks, pal. Okay. So, Tanya, what do you use? I don't know where anybody is in this scene. It's just starting going the other way. All right. Tell me, what does that notation mean on a number? What does that mean? 1 over 2. So you'd say that's an exponent and it means reciprocal, yeah? What does this notation mean on a function? Does it also mean reciprocal? No, it means inverse. Okay, so obviously be careful. So how will they write it if they want you to do the reciprocal? They'll actually write it this way. We'll say find 1 over f. Right? Now, that said, cool, it's the inverse. The question is, where's the 2 go? Well, that's still an x value. Still an x. Except now you're putting it in the inverse. So it's 2 equals y cubed plus y. Please do not bust out your rational roots there, Descartes' rule of signs and low, least, and upper. Well, that's just common sense. What's what? 1. There you go. Done. Okay? All right, so the answer to that is 1. I think. 22, check. 21. Question on 21. 21? No? Yes, okay. That replaced. Okay, 21 is on the area of the region x and x and the x-axis. Yeah, no calculator, okay. So, how do you find the area x sine of x on 0 to pi First, I don't know if I really need a good graph, but I do need to know if it's above the axis or below so I get positive area. So on 0 to pi, is this positive or negative? Positive. So I'm just going to say it looks like that. I don't know exactly, nor do I care. But actually, I care a little. From 0 to pi, the area of the region. So I imagine the integral is fine. 0 to pi of x sine of x dx. For the rectangles, dx is the width and x sine of x is the height of those rectangles. How do you integrate that? Ultraviolet voodoo. There are a couple different schools of thought as to where the bounds go in terms of notation. Where did you let u equal, x or sine of x? X. And therefore du is dx, and v is sine or sorry, cosine or negative cosine? It's negative cosine. All right, so this would be something like uv negative x cosine of x. I would take the negative out of the integral and combine it with the subtraction to be positive. Cosine of x dx. And as far as the limits, you could either do an evaluation bar here and do them there, or you could just say, hey, I'm about to evaluate this once I'm done. That's the way I was talking. At any rate, when you do this, the antiderivative of cosine is sine, so you get something like that. So, negative pi, what's the cosine of pi? Negative 1 plus sine of pi is 0 minus 0 plus sine of 0 is 0. So I get pi. All right, 25. Is 25 still a question? Yes. Okay. We're getting closer. So, this is a good one. So this will be reinforcement of what we just talked about. Did the finding the zeros go okay? Did the top factor or solve pretty well, or was it disastrous? How did the top zeros go? Did it factor? Yeah, no. So 2x cubed minus 2x squared plus 3. So, did you try a little synthetic to find the zeros, or what'd you do here? Is that the question? So 1's not 0. Guess I'll synthetic. I was thinking maybe guess and check. What are you feeling about negative 1? Alright. Question though is what's left when you take it out. Come on. I am getting a little tired and I was hoping to avoid this, but it's alright. 0, 6, so 2, negative 2, negative 6, 6, 6, and negative 6 is a 0, so I feel like this is equivalent to x plus 1 times 2x squared minus 6x plus 6 over x minus 2, or x plus 1 times 2 times x squared minus 3x plus 3, and that does not.
Why did you synthetically divide with negative 1?
I just by guess and check, I kind of saw that was going to be the 0. And so the question in my mind was not, did that work? I knew it would work. The question then is there anything else? Because a cube could have other roots. So that's why I did this, so that I could take a gander at the reduced or depressed equation. That quadratic has imaginary roots. So there's one real x-intercept. Cool? So I know I have an x-intercept at negative 1, a vertical asymptote at 2. In terms of the end behavior, I could divide by 2 and see what I got going on there. 1, negative 2, 0, 3, 1, 2. Oh, that's nice. Oh, that's just getting better and better. So 3. What is the asymptote? If I divide 2x cubed by x, it's y equals x squared. Yay? Oh, this was supposed to be shin splints. Darn. I should have done the original, huh? 2. Gosh, darn it, I am running on fumes, baby. I'm running on fumes. So 2 -4 is 0, 6, 2, 4, it's still zeros. That's delightful. 0, 0, 0, 6. So what's the parabolic asymptote? 2x squared, a little steeper. So a little steeper, 2x squared is here. It's really steep. Okay? And then in terms of graphing, I'm feeling it'll follow the parabolic asymptote till it hits that 0. Because that 1 is first degree, there is a sign change there, and it'll head down. Because x minus 2 is first degree, there will be a sign change there, so y's will go from negative to positive, and so I'm feeling there. Cool? Okay, 25, check. 5. Question on 5. 5 is book or replaced. Okay, so x equals y squared looks like this. And y equals negative x plus 4 looks like this. But I think they said first quadrant only, eh? Okay, so if this region is revolved, first of all, around the x-axis. I said this yesterday, but I'll say it again. I don't choose, I'm going to use shells. I choose what variable is best, what variable is least amount of work. So if I use an x slice, then what kind of workload am I looking at? 2 integrals. Okay, if I use an x slice, then I have one region there and a totally different region there. 2 integrals.
Pardon this quick interruption. It's time to release the junior high student council, senior high student council, marching band. And also, please retain your students for 6 hours till the marching band comes through. At 1:40, all the 12th grade sports athletes should be in the big gym. Thank you.
Okay, so what about y? Will y be 1 integral, or 2? 1. So if I use y and I'm going around the x-axis, then that slice of y gets revolved. What's made? That's a cylindrical shell. That is not a washer, it's a cylindrical shell. So I'm thinking about unwrapping this and saying what's length, width, and height. So what's the depth or thickness? dx or dy? dy. This guy. How do I find that distance? Or what does it relate to in the original? This is the circumference, yeah? So when I unwrap that, this distance around becomes this distance. It's the circumference. 2 pi, is the radius x or y? Y, okay? What about this distance? This distance is this distance. And it's lots of different things, but it seems like I could always find it by right minus left. What's the right? The line or the curve? The line, and the left is the curve. So I'm going to do line minus curve, and will I do that in x terms or y terms? Y terms. So if it was x equals y squared, then that's already in y terms. This is y equals negative x plus 4. So when I say integrate this bad boy, I'm going to take these dimensions, 2 pi y, and line minus curve in y terms. Talk to me. What's line minus curve in y terms? The line is 4 minus y, and the curve is y squared. And the limits, I think, were something like 0 to 1 point. They weren't something clean. 1 point something? What was it? 562 or something. Okay. That should get you going on A. Are we good? Okay, now B. B is if I take this region and go around the y-axis. Now, has the fact that x stinks changed? No, the fact that x stinks is still there. It's still 2 integrals if I use x. I don't want to use x. I want to use y. So if I use a y slicer on the y-axis, then that's a washer, right? So volume is pi, not 2 pi, pi, big R squared minus little r squared dy. What's big R? Big R is this distance here. So that's the distance to the line or to the curve? The line. So the line in y terms is 4 minus y. Little r, which is in here, here's little circle radius. Little r is y squared. And again, the limits are still going to be the same, whatever they were. Okay? Now we have an answer for you. Sorry. Okay. Any other questions on 87? 4. 22 on 86. 22 on 86 is hard. All right. 4, did you say? Okay. 4. 4 is, yeah. Okay. So you are given, or you know, that acceleration due to gravity is negative 9.8 meters per second per second. Velocity is the antiderivative of acceleration, which is negative 9.8 t plus a constant. And because it's thrown horizontally, and this is a vertical idea, then the horizontal velocity is something, but the vertical velocity is 0. So the vertical velocity equation is negative 9.8 t plus 0. I don't know why I just wrote that. And through the same kind of process, the height, or the y, is the antiderivative velocity. So that's negative 4.9 t squared plus a new constant. And I think they tell you the initial height is 200 at times 0. So negative 4.9 t squared plus 200. Do you agree on A? Cool. B. All right, so check this out. He's throwing the ball, or she's throwing the ball off some 200-meter high field, and we want to know how far it goes. So you could even think of that as x when it hits the ground, or delta x, whatever you want. But how far it goes horizontally is going to depend on how fast he threw it and how long it traveled. So I'm feeling something like the velocity in the x direction times the time it was in the air. Yeah? I think they tell you the velocity in the x direction is 40 meters per second. That's not hard. The hard part is we don't know how long it's in the air before it hits the ground. So how do I find it? How long is it traveling? How do you find it? Multiply. Multiply what? Yeah, that's true. I will multiply it, but again, I don't have the time, so it's hard to multiply. Okay, so I need to find when the height is 0, and the height is 0 at square root of 200 over 4.9. Yay? You agree? Okay, so if you take that amount of time it's in the air times, that's in seconds, 40 meters per second, that tells you it travels blah meters. Okay? Okay, anything else on 87? All right, how about 87 fun sheets? How did it go? Did anybody get all of them correct? All right, excellent. Some people just have an knack for this. Some people are like me and it takes forever. I think I probably would have got all these wrong my first time, but I'm slow. Which one would you like to walk through? 5, right? I heard 7 also. 5. Okay, fun 87 5. All right, if I recall, that was the log curve one, yeah? With lots of parts. So, 5, y equals 3 plus log of x is this guy shifted up y equals e to the x is this guy. So hopefully your region was this kind of banana looking figure, yeah? Now, if we take that in 5, it says revolve it around the x-axis. So if I take that and revolve it around the x-axis, I would get this kind of figure. All right, now the question is, what variable do they ask for? They ask for y. When I draw a y slice, so I go this way, side to side, or this way, up and down? Side to side. So take a slice, draw it like that, and then say what happens if I revolve that. What is made? And what is made is a shell. A cylindrical shell. All right. So if I have a cylindrical shell, most people just say shell, is the thickness dx or dy. dy. This distance here, what does it correspond to in terms of this cylinder? Circumference, and is the circumference 2 pi r of an x, or 2 pi the radius is what? 2 pi y. Okay, this guy here comes from this distance here. It's constantly changing. So I guess you could say it's like x minus x, but really it needs to be the curves in y terms, yeah? So it's the exponential in y terms minus the log in y terms, and that, I believe, in the last class was the big issue. If you do the exponential in y terms, then what is that? Natural log of y. And if you do the log in y terms, it's what? E to the y minus 3. So when I go to set this up, it should actually be 2 pi y log of y minus e to the y minus 3 dy, and the limits for y are something like, I stored these obviously, but rounded are 1.174 and 3.132. I'm not sure I got my answer. 6.135. Which does check the other way. Well, how'd that go? Oh, the beauty is that you now have ways to check, and if you have time on the test, you can say, oh, I'll check it the other way, and you can know, you should know if you did it right or not. Okay? Anything else on that volume sheet you'd like to talk about? 7. Let's do 7 and 8. 7 is same curves around the y-axis using x. So you have this curve, y-axis, using x. If you use x, do the slices go up and down or side to side? X is this way, yay? It did not make my slices. Cylindrical shell or washer? Shell. Okay. So, shell unwrapped is this. The thickness is dx or dy. dx. This bottom edge corresponds to the circumference, so it's 2 pi x or y. X. This is this distance. It's lots of different distances. But I feel like it's upper minus lower. So upper minus lower, what's the upper curve? 3 plus log or e to the x? 3 plus log, and lower is e to the x. So the volume is 2 pi out front in the integrand. X times 3 plus log of x minus e to the x dx. And these, the x limits were different obviously. 0.161 to 1.14. Aye. Cool. What other questions? Wow, we're so caught up. I'm not sure what to do with myself. It's delightful, isn't it? Alrighty then.
Yell it out. Wait, number
12. 12, 12. So y equals x, 1 over x squared plus 1 has no zeros. As x gets big, y gets small, and the max value is 1. Classic curve involved this region around the y-axis. Cool. It says use y. If you use y, wow, that sucks. No, it says use x. Oh, good, because y would stink. Y. Okay? Shell or washer or disk? Shell. Okay? What's the thickness, dx or dy? What's this edge? And what's this edge? So that then is time to integrate by use of. And the limits are always the original region, not the revolved region. So you're in one cell. I use of. Okie dokie. Feels like it's left. Is that allowed? I'm so tired, I don't even care. Hi. Alright, so. Yes. So, first two, you've got to repeat this. It's got to be, if it's differentiable, it's also got to be continuous. So start by saying, in order to get continuity, the limit to the left is 0, which switches a to the x plus b, x, and then needs to equal the limit of x raised to the right of 4, which is x squared plus 1. We have to make sure that that'll probably give you a way to approach. Then use differentiability. You don't have to use differentiability here. You can just say the variance from the left will be a to the x plus b. And then it's the equal will be the same as the variance from the right. Those two things you can use a pair of AB equations that you can solve. Okay? You're welcome. Hi.
I'm gonna go down to the.
Oh yeah, senior volleyball. Thank you for checking first on that one. I appreciate it. All right, people.